For the given right triangle, label the adjacent side, opposite side, hypotenuse for the indicated angle. Alright, so the indicated angle for the problem is the theta. I put the theta and the phi in because I'm going to use that for 4. Well, we can do it all at once, but so the side opposite you can see is, this side going straight across, and then the adjacent, it means that it has one of the sides of the angle, and of course the hypotenuse is the side opposite the right angle here. So opposite theta, that's the opposite side. Adjacent means that it's one of the sides of the angle. Now if we jump to 4, because this kind of relates, is that what's the relationship between the two acute angles in the right angle? Well, since the sum of the angles is 180 and I subtract out the 90, that means that theta is equal to 90 minus phi, or you could say that it's equal to 2 pi, or pi over 2 times phi. Either way, they're what we'd call complementary angles, right? So number 2, when a right triangle with a hypotenuse of 1 is placed in a unit circle, which side of the right triangle corresponds to the x and y coordinates? So I know we've kind of already talked about this, but the x, which is from 0 to whatever this value is, that's the x value. So the cosine is the x, right? X equals cosine, which is the opposite, opposite adjacent over 1 is cosine of your angle. And then, of course, the sine is the, this is the vertical here, so that'd be the opposite over. So y is equal to the sine of whatever your angle is. In this case, I'm just calling it theta. The tangent of an angle compares to which sides of the right triangle? Well, this just goes back to the SOHCAHTOA, right? This is a classic way to remember the connection. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent, which answers question 3, is the opposite side over the adjacent side. TOA, tangent, opposite, adjacent. Explain the cofunction. Well, it turns out that because if you think this is where the phi comes into play, right? The cofunction says that the sine of the theta, which for example would be opposite over hypotenuse, this opposite side is the adjacent side of phi, so that would make it the cosine of phi, and vice versa. If the cosine is the adjacent over hypotenuse, that would be the opposite. So you can see that if I take 90, which is what we do in 4 about the converting them, right? So the cosine of t is equal to the sine of pi minus t, because based on the way I drew this here, this would be say theta, and then this angle here would be the phi, like that. So t would be theta and this would be phi. Well, phi is just like we calculated over here, it's just the pi over 2 minus phi. So all they're really doing is substituting it into this. So a simple question like this means that what's the cosine of 34 degrees subtracted from 90, right? You get 56, so it's equal to the sine of 56 degrees, whatever that may be. Alright, so we're finding the missing sides where we have a right triangle, where we have A and opposite side is little a, and angle B, opposite side is little b, and then opposite the right angle, the hypotenuse is C. Now, number 12, they give us the tangent of A is 5/12, and B is equal to 6. Now, this is a ratio, so that means that it doesn't have to actually be those values, which obviously it's not. So what we do have, we can also write as A over, here's A, opposite over adjacent, so A over B. A over NB is 6. Now we can multiply that, we get 30 over 12 is 6. So let's see, what does that simplify? 6 divides both of those, 5 and 2, so we get A is 5 halves. Now c we just have to calculate with the Pythagorean theorem, so we get a squared plus b squared, because they gave us that, is c squared. So I get 25 fourths plus 36 equals c squared. So this would be 25 fourths plus, now 36 times 4, that's what, 24 and 120, so 144 c squared. Now we add them together, that gives us 169 over 4. Take the square root, so c is equal to the square root of 169 over 4, and 169 is 13 squared over 2. And so we have our third side. So we have a equals 5 halves, b is equal to 6, and c is equal to 13 halves. Like that. Alright, for number 14, they give us sine of b is equal to 1 over the square root of 3, and they give us that a is 2. So again, we have our a, big B, little b, c, and little c. Now this time they give us sine, which is 1 over the square root of 3, or another way is opposite over hypotenuse, so they give us 2 over c like this. So to solve this, let's just do a little cross multiplying. So we get c times 1 is equal to 2 square root of 3. So now again we can just use the Pythagorean theorem, right? So we get 2 squared plus b squared is equal to c squared. So this is 4 plus b squared is equal to 4 times 3, which is 12. So b squared is, subtract the 4 over to this side, we get 8. So we get b is square root of 8, which that's 4 and 2. So square root of 4 is 2, square root of 2. So we have our a is 2, b is 2 square root of 2, and c is 2 square root of 3. And we have our third side. Alright, for this problem, we're given a triangle, right? A, 8, and 10. So now we're supposed to find all of the trig functions for angle A. This isn't so bad. So this is just do the Pythagorean theorem to get this side. So you get 10 squared plus 8 squared is c squared. This is called a c. So this would be 100 plus 64 is equal to c squared. So c is the square root of 164. Now, can we simplify that? Probably. Let's just do it as best we can. So let's see, 2 would go into that 80 2 times, 2 would go into that 41 times. So this looks like it's going to be 2 square root of 41. A little prime factorization so that we can figure out the square root, because for every 2 of these, we can pull one out. Alright, so we have our 3 values. So if we're going to write down the trig functions, right, sine of A is opposite over adjacent, like this. And then if you want to square root or rationalize the denominator by multiplying the top and bottom by the square root of 41, right? So this would give you, let's see, that goes in there 5 times. So this would be 5 square root of 41 over 41. If I have the cosine of A, that would be 8 over 2 square root of 41. Well, that's just a 4, so this rationalizes the denominator. So I get 4 square root of 41 over 41. Tangent of A, that would be opposite over adjacent, which would be 5 over 4. Let's see, 26, like cosecant, it's the reciprocal of sine. So instead of using this one, let's go back to this guy right here. We're at 5 over, so this would be 41 over 5. And then if I do secant of A, that's the reciprocal of this one. So let's not use this one. Let's go back to here. We're at 4 over 41 and just flip it over. So it's the reciprocal. And then cotangent of A, just the reciprocal of that would be 4/5. Alright, so for 34, what we're going to do is we're going to try to find all the angles and all the sides so we can, right, so that we know what all of the so we have this information right here, right? This is from the picture. So we want to find A, B, well, we got C, that's easy enough, right? And we want to find B, C, this C we know, that's 90 degrees, so that's not. So we have capital C, which is 90 degrees, and little c, which is 10. And we also have A here, they give us 65 degrees. So of course B is easy to calculate, that's just 90 minus 65, which would be 25 degrees. So we have that angle right there, that's 25 degrees. Now let's find the sides. Now, we could do it, I don't know, now that we have all the angles, we could do it a bunch of different ways, but let's do it based on the 65 here. So what am I going to do? I'm going to take the opposite over hypotenuse, so that would be A over 10. That's equal to the sine of 65 degrees. So that would tell me that A is equal to 10 times the sine of 65 degrees. Put in my 10 times the sine of 65, and because I have it set for radians, I don't want to switch it. I just go to angle, degrees, and so we get A is equal to 9.06307787, and round off to however many digits we feel like. Alright, so we have our side, A. Now we could use the quadratic formula now that we have A and C, but let's not. Let's just do it a different way. So this is the adjacent side, so that would be B over 10 is equal to the cosine of 65 degrees. So just multiply that over and I get B is equal to the 10, here let me write it better, 10 times the cosine of 65 degrees times the cosine of 65, get that angle, degrees, enter. So we have B is equal to 4.22, whatever. So I have B is equal to 4.226182617, and we have our three sides, the one that was given, and then our other two sides here, B and A. Alright, let's try a few of these word problems or story problems, whatever you like to call them. 46. So it says, a radiator tower is located 400 feet from a building. So here's I'll draw in a radio tower here. Boop, boop, boop. And it's 400 feet from some sort of building here. Doesn't say how tall it is yet, so it's 400 feet. It says, a person determines that the angle of elevation to the top of the tower and the angle of depression to the bottom of the tower, 36 and 23, right? How tall is the tower? So in other words, here's somebody at some window here. I don't really know where it is. Let's draw this eye line here. And the angle of elevation would be 36 degrees. And the angle of depression to the bottom, that would be 23 degrees. And we want to know how tall it is. So what is the height of the tower, the whole thing here? Well, let's call it capital H for the height of the tower, like this. So let's just break it down into two pieces. So let's call this x and y, something like that. So we know that h is x plus y. So if I can find each one of them, then all I have to do is add them together, right? Well, I do know this side, which is the adjacent side for both of these angles, and I know the opposite, or I don't know the opposite. I need to know the opposite. So that means that the tangent of 36 degrees is equal to x opposite over adjacent, which is 400, and the other one, tangent of 23 degrees, is also opposite over adjacent, because this is 400. This distance here is the same as that one. So we can see if we multiply across, x is equal to 400 times the tangent of 36 degrees, and y is equal to 400 tangent of 23 degrees. So my height is just add the two together. And just plug it in. Tangent 36 angle plus 400 tangent 23 angle degree, and we get 460.4 feet. And we have our height of our building. Alright, let's try another one. So the next one we have is 50. There's an antenna on the top of a building from a location 300 feet from the base of the building. Alright, so you have this, here's our tall building, here's the antenna. From a location 300 feet from the base of the building, angle of elevation to the top of the building is 40 degrees. So here, angle of elevation is 40 degrees, and we're 300 feet from the building. From the same location, the angle of elevation to the antenna is 43 degrees. So that's 43 degrees, that angle of elevation. Find the height of the antenna. So you want to find this, okay? So what we do know, again, this is just two triangles, right? Here's one with 40 degrees, and this is 300. So we could find this height. Let's call it B for the building, because that's the height to the building here, right? So that would be opposite. Tangent of 40 degrees is B over 300. So the height of the building is 300 tangent of 40 degrees. And now the 43 is all the way to the top. So this would be, if I have 43 degrees, right, this would be x plus b. So we get, again, this is 300, right, because that's still the distance. So that would be opposite, right, tangent of 43 degrees is equal to opposite, which is x plus b over 300. So we get multiplied over 300, tangent of 43 degrees is x plus b. Subtract the b over, so the height of the antenna is 300 tangent of 43 degrees minus b, which is this thing we calculated up here, 300 minus tangent of 40 degrees. Now I go to my calculator, 300 tangent 43 degrees minus 300 tangent 40 second angle degrees, and we get the height of the antenna is 28 feet. Alright, so we get x is equal to 28 feet. Alright, so that's the height of the antenna. Now let's go to, let's see, is there another one? Do I have another? Oh, 52. Let's do the 52. So I have, says the 33-foot ladder leans against the building. 33 feet. Let's see. Against the building, the angle between the ground and the ladder is 80 degrees. How high up does the ladder reach? So we want to know this. What's the height of the ladder here? So if I take opposite over hypotenuse, that's sine of 80 degrees is equal to h over 33. So the height is just 33 times the sine of 80 degrees. So I just plug that in my calculator. Sine of 80 degrees. I get 32.5. We'll round it off. So I get 32.5 degrees for that one. Alright. Assuming that a 300-foot giant redwood grows vertically, if I walk a certain distance from the tree and measure the angle of elevation to the top of the tree to be 60 feet, how far from the base of the tree am I? So we have our, our tree here, and we know that it's 370-foot tree, and you walk a certain distance so that your angle to the top of the tree is 60 degrees. How high is the tree? So this is just opposite over adjacent. So 370 over d is equal to the tangent of 60. So these could just swap. So you get d is equal to 370 divided by the tangent of 60 degrees. 370 divided by the tangent of 60 degrees. And we get 213.6 feet.